Jingle bells, jingle all the way. Hey guys, we're back with day 64 here. A little holiday spirit as we get ready for our test on Thursday, tomorrow. So I made up two inverse problems. We went over the ones in class. I wanted to just do two more to take a look at how we solve them. So these are two problems you've never seen before. So what I want you to do is, I'm starting with those, since some people are fine with questions 7 through 10. So go ahead and take a look at question 1 here. Try and solve it on your own. Pause the video, and then we'll go through how to do it. Okay, so number 1 here, it says, let f of x equal the square root of x cubed plus 8, and let g of x be the inverse of f of x. Okay, so it's pretty explicitly stated there that g and f are inverses. Then it says the point 24 is on f. Okay, that's absolutely crucial information because they want us to find g prime of 4. Again, with these inverse problems, what I always want you to do first is I want you to find the corresponding points, right? So the fact that they tell you the point 24 is on f is a dead giveaway that that's going to be very important. So here's what we know. Since 24 is on f, we know that f of 2 equals 4. So what I want you to think about is, what would that corresponding point be, right, on the graph of g? Well, we know inverses just have our x's and y's flipped. So we know that g of 4 equals 2. That's our corresponding point. This is obviously very important because we're looking for g prime of 4. So what we know is that g prime of 4 is simply the inverse of f prime of 2. So obviously we need to find the derivative of f here. But then when I find f prime, I'm actually plugging in 2. Please don't plug in 4. Okay, that will be going down the wrong path. We don't want to do that, right? So f prime of 2 and g prime of 4 will be inverses of each other. Notice that the x values don't match. That's okay. They're not supposed to match. The x value on g is supposed to match with the y value on 4. And vice versa, right? The y value on g is supposed to match with the x value on f. So what I need to do here now is figure out f prime of 2. Right? F prime of 2 will be very important because the easiest way to do this is just find f prime of 2 and then just take the reciprocal of that, and that will be g prime of 4. So before I do f prime of 2, I need to do f prime of x. Okay? Again, we might want to think about this function as x cubed plus 8 to the half power. Okay, so we need to remember that square root simply means to the half power, so it's x cubed plus 8 to the half power. F prime then would be half. It's a chain rule, so because we have a function x cubed plus 8 within another function, the square root of x. Right? So I do the derivative of the outside while keeping the inside the same. Right? Don't forget to put this negative half up top. Now I need to multiply by the derivative of the inside. The derivative of the inside would be 3x squared. Cleaning this up a little bit to make it easier to evaluate in a second, I see that this 3x squared is going to end up on top. This 2 and this negative half power are going to end up on the bottom. The negative half power now converts to a positive half power, which we know is a square root. So there's f prime of x in a nice, easy to solve form. Okay? If you're struggling with that, go back and watch the chain rule videos, right? Now let's find f prime of 2. I'm going to plug it in. I got 3 times 2 squared over 2 square root 2 cubed plus 8. That makes the number 12 on top. And that makes 2 cubed is 8. 8 plus 8 is 16. Square root of 16 is 4. 4 times 2 is 8. So I get 12 over 8. 12 and 8 both divide by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So I know now that f prime of 2 equals 3 halves. So now I know that g prime of 4 must be the reciprocal of 3/2, so that's 2/3. Okay. Again, the key here, when you get this problem, don't just start doing derivatives and plugging stuff in without thinking first. Think first, what's our crossover point, right? What are our points that correspond? Okay? That's going to be important in the next problem as well. So let's take a look at the next problem. Once again, I'm going to have you pause the video here. Right? You can watch me solve these all day, but it won't really start to sink in until you try it on your own, right? I don't want the first time that you try it to be in a testing situation, okay? So pause it here, try this one in your notes, and then watch to see if you got the answer right. And if you're really stuck, then watch me solve it. Okay, we're back. So here's what it says. Above is a table of x, f, and f prime values for the increasing function f. Now they tell us g of f of x equals f of g of x equals x. Well, what the heck does that mean? Then it says find g prime of 5. Well, we know from algebra 2 that when we do a composition of two functions, if they equal each other and equal the value x, this is code, right? This is code for g is inverse of f. Sometimes they lay it right out there for you, make it obvious, sometimes they don't. Now again, we want to find g prime of 5. Okay? Now, when I look up at this table, I see 5s all over the place, right? Also notice, the question is about g prime of 5, but the table is all about f, right? What I need to figure out here is what is my crossover point? So instead of focusing on g prime of 5, let's think about g of 5 real quick. Okay? I want to identify what my crossover point is. Okay? This one's a little bit trickier, I think, than the problem before. Okay? Because we now have tons of points, right? But what I know here is that I'm caring about g of 5. So I know the x value on g that I care about is the x value of 5. Well, the corresponding point on f would not have an x value of 5. It would have a y value of 5, right? So when I'm filling out this table, right, this is my x value right here. That's got to translate to the y value on the other one. Okay? Now what I do is I go up to my table and see where do I have a y value of 5. So I'm scanning this column right here for the number 5. I see it right here, and I know that f of 3 is 5. So I know that g of 5 is 3. Now this number right here is really inconsequential to our answer, but it's kind of nice to complete that table. If 3, 5 is on f, 5, 3 is on g. That's important because now I need to, just like in the other one, right? I'm not going after f prime of 5, right? I'm going after f prime of 3. Well, I can get that from the table. F prime of 3 is 6/7. Therefore, what must g prime of 5 be? Well, it'd be the reciprocal of that, so 7/6. And that's my answer right here. Do not fall for this red herring. The only reason that column is included on the table is to trick you into getting the wrong answer. It's a bad column to look at. Remember, the x values won't match on inverses. The x of one matches with the y of the other. So I don't scan the x column for 5. I scan the y column, or the f of x column, for 5. Okay? Very, very important. These problems end up being very easy once you work at it a little bit, and once you have a good understanding and think about it a little bit, okay, but they can be very tricky. That's why not very many people get these problems right, which means if you do get it right on the AP exam, right, that's putting you ahead of a lot of people who get that question wrong. Okay, let's take a look at the questions 7 through 10 briefly here. These are our L'Hopital's rule limits. We got to make sure that we actually can use L'Hopital's rule to solve for it. Our first, the first thing we try and do when we have a limit is see what happens when we plug in the value, right? So I'm going to plug in 0 into this function here. Notice these are all free response questions, so you're going to have to make sure that you use good notation here and things like that. So the first thing I do is I plug in 0 for x, and when I do, I get e to the 5 times 0 minus 1 over 0. 5 times 0 is 0, e to the 0 is 1, 1 minus 1 is 0. So I get 0 over 0, okay? That's a case where I can use L'Hopital's rule. What you need to make sure you do tomorrow, I'll be strict on this tomorrow, so pay attention closely. Using L'Hopital's, we need to say that. Using L'Hopital's, I'm going to write a new limit. My new limit is the limit as x goes to 0, and I'm going to do the derivative of both the top and the bottom. Okay, the derivative of e to the 5x is e to the 5x, but it's a chain rule, so I have to multiply by 5. The derivative of negative 1 is 0, and the derivative of x is 1. Okay, a couple of things I need to see tomorrow. I need to see that you confirmed that you can use L'Hopital's rule. I need to see that you stated that you're using L'Hopital's rule, and I need to see this limit notation. All three of those things have to be present to get full credit. Okay? Then you have to execute the derivative properly as well. Remember, this isn't a quotient rule problem. This is a L'Hopital's rule, so we just do the derivative of the top and we do the derivative of the bottom. We don't have to follow the quotient rule. Okay? After we properly do that derivative, now again, the next thing we do is plug in 0 for x, and we get 5 e to the 0 over 1. E to the 0 is 1, 5 times 1 is 5, 5 over 1 is 5. Again, I need to see this tomorrow, I need to see this tomorrow, and I need to see this limit notation tomorrow. Practice it. Make sure you don't forget those things. Okay, number 8. So once again, I have a limit problem, so my variable in this problem is x. So I'm going to start by plugging in 0 for x. When I do so, I get sine 4 times 0 is 0. And I plug in 0 for x. Sine of 0 is 0. Therefore, I get 0 over 0. I need to see that tomorrow. I also need you to say using L'Hopital's. Make sure you say this. You can't just do it without showing that you can. The AP test is strict, so I'll be strict. Using L'Hopital's, again, don't just write the derivative and keep going. Rewrite your limit. Say limit x goes to 0. Now I'm going to do the derivative of the top and do the derivative of the bottom. The derivative of sine of 4x, that's again a chain rule. It's going to be cos of 4x. I do the derivative of the outside, cosine, with respect to the inside, 4x, times the derivative of the inside, which is 4. All divided by 1, because that's the derivative of x. You don't have to write that over 1 if you don't want to, but you can. Now, again, I'm going to plug in 0, and I'm going to get 4 cos 0 over 1. Cosine of 0 is 1. 4 times 1 is 4. Again, really make sure all three of those things are present every time you do this. Okay, number 9 is just a little bit different because I'm using h instead of x, but whatever, no problem. H is now my variable. I'm going to plug in 0 for h. When I do that, I get cos pi over 2 plus 0, which is pi over 2, right? Minus cos pi over 2 over 0. So I get 0 over 0. Check. I can use L'Hopital's, so I'm going to say that I am. Using L'Hopital's. Check. I made sure to remember to say that. Limit h goes to 0. Now I'm going to do the check. Now I'm going to do the derivative. Okay? Now notice that first term has a variable in it. It has an h in it. So I'm going to have to do the derivative of cosine of pi over 2 plus h. That would be negative sine of pi over 2 plus h. The derivative of the outside with respect to the inside times the derivative of the inside. Well, the derivative of pi over 2 plus h is 0 plus 1. So I'm going to multiply by 1, which I don't need to write. Now, the derivative of this, cosine of pi halves, is simply 0. There's no variable. That's a constant. The derivative is 0. The derivative of h is 1. This time I'm not going to write the over 1. Okay? You don't have to. Now we can plug in 0 for h, and my answer is going to be negative sine of pi halves. Right? On my unit circle, pi halves is right here. That's the point 0, 1. This one is sine. So I know sine of pi halves is 1. But it's the opposite of that, right? Because it is negative. So I get opposite 1, negative 1 is my answer. Okay? Last one, number 10. I realized on the key I didn't quite finish doing this one. So let's take a look at it. So when I plug in this limit, I get ln of 5 plus 0, which is simply 5, minus ln 5 over 0. Okay, that's plugging in 0 for both of those h's. Well, ln 5 minus ln 5 is 0, so I get 0 over 0. Okay, check. Using L'Hopital's. Check. Limit h goes to 0. Check. Okay? And now I'm going to do the derivative of the top and the derivative of the bottom. On top, I only really have to worry about the derivative of the first term, because that's the one that has the variable in it. The derivative of ln 5 is going to be 0. The derivative of h on the bottom is going to be 1. So that takes care of the 0 on the bottom. So the derivative of ln of 5 plus h is 1 over 5 plus h. Times the derivative of 5 plus h. Well, the nice thing is the derivative of 5 plus h is simply 1. You don't need to write that times 1 if you don't want to. Okay? But you can. Again, the derivative of ln 5 is 0. The derivative of h is 1. So it's like this whole thing over 1, which I'm not going to write. So I'm just going to write it as 1 over 5 plus h. Now I'm going to plug that in. And I'm going to get 1 over 5 plus 0, or 1. Okay? So, study this. Be ready to go for tomorrow. You guys can do this. We'll see you then. Have a good one. 2 chains, bye.